Hello everyone, welcome back. In this lecture, we will solve this problem related to the projection of lines. In this particular question, we have line AB in which point A is 30 mm above HP and 20 mm in front of VP, and its left view is 60 mm long and makes 60 degree with the X1 Y1 line. So here we have left view or left side view, which we will draw on RPP or right projection plane. So what we have to do is we have to draw the three views. First one front view, second top view, and third one is left view. So, and we have to find the true length and true inclination with HP when the line makes 40 degree with the wave. Okay, let's start with this first point A, which is 30 mm above HP and 20 in front of VP. So 30 above HP and 20 in front of VP. So now this point will be our, it is in front view, so it will be A dash, and this one is A. Change these to the main drawing layer. Okay, now this is the first condition. Now so this is the projection of initial point. Now left view is given, left view or left side view, so it will appear on the RPP, right projection plane. So we will start with this left view. So we know RPP will appear to the right of this projection. So I'm just taking a reference line just up to this much distance. Clearly RPP is not given. Previously in points we have RPP at a certain distance, but here we do not have the distance. So what we're gonna do is roughly I'm taking the reference line over here and going to mark this with x1 and y1. So this is a reference line x1 y1, with the help of which we are going to draw our left view, which will be on right projection plane, RPP. RPP means right to the this projection. So this is a reference line. Now to find out our side view of this point A, what we need to do is from this point of intersection, line x1 y1 and xy, from the point of intersection we need to draw a inclined line which should be at 45 degree with the xy line, and it should be in the direction of top view. Top view is in the downward direction, so to the right side we will draw an inclined line which will be at 45 degree with the xy line. So like this, just going to stretch it a bit and press shift at the rate length, keep it, tap, angle should be minus 45. It is in the clockwise direction, that is why we are using minus 45. Okay, now you can check whether it is at 45 or not. Click here. So this line is at 45 degree. Now our very next step is to draw a horizontal line from point A or from top view. This horizontal line is going to intersect with this inclined line. Okay, so this line will intersect here, so I need this point of intersection. Okay, now from this point of intersection we have to draw a vertical line. This line should be in the direction of front view, and our front view is above the xy line. So draw this line like this, and now from the front view A dash, you have to draw a horizontal line which will again intersect with this vertical line, and the point of intersection is our projection of side view. So this is our side view, and side view is denoted by A double dash. Okay, now in the question it is given side view is 60 mm long and makes 60 degree with the xy y1 line. This x1 y1 is our reference line, x1 y1. So what I'm gonna do is just draw the side view which is given, and side view is 60 mm long and at 60 degree. So this angle x, and the line makes an angle of 60 degree with this xy line. Just drag it a bit, shift at the rate, length should be 60, tab, angle should be 60 between x1 y1 and this a dash b dash. So I'm going to take 30 degree. So this line is 30 degree with this one. That is where you can measure this one. This is the remaining angle, which should be 60 degree. So the second point of the line is B. So the end point of this line will be B dash. Going to change it to the main drawing. Now you have to check whether it is at 60 degree with the x1 y1 first and this x1 y1. So this is 60 degree. It is good. Now you have to check whether it is of the required length. So this length should be 60. Okay, good. So this is correct. Now we have these. This is the given condition in the question, and other than this, we have one more condition. The line makes 40 degree with the VP. So the true line in the top view is given, but only the angle is given. So we do not have the length of the true line. So what we're gonna do is just draw as it is given, 40 degree with VP. So from point A, draw a line which will be inclined. So I'm going to take this much length because we do not have the exact length. So just press shift at the rate, tab, and angle should be 40 minus 40 because it is in the clockwise direction or in the downward directions. That is why I have taken minus 40. Now check the angle. So these are the given conditions. We have side view, we have projection of point A, and we have true line in the top view which is at 40 degree, but the length is not fixed. So we need to find the length. Here we need to find the length. We do have the angle, but we do not have this length. So let's start with, from these given condition, what we can do is, from this point B, which is the side view, I'm going to draw a locus. So for front view, we will only draw a horizontal line which will be again the locus for the front view. Means the front view, in front view we have two lines. We supposed to have two lines to complete this projection. We supposed to have one true line and one apparent line here, and we have one true line but length is not fixed, and one apparent line here. So in front view with this locus, you can understand this, the true line and apparent line, the endpoints of true and apparent line will lie on this horizontal line because we have considered this locus from this B double dash. Again for the top view, this is for the front view. Now for the top view we need the locus. So what we're gonna do is, from this B double dash, I'm going to draw a vertical line which will intersect with this inclined line. So up to here, so this is a point of intersection. Now from this point I need to draw a horizontal line. Now this is the locus for top view. The endpoints of true line and apparent line will appear on this horizontal line. So with the help of this, now we know the true length of this true line. So just remove this extra part, and this point is our endpoint of true line, which is denoted by B1. Now we have true line in the top view. So what we can do is, with the help of this true line, I can draw apparent line in the front view. So again the process is, from the true line you need to draw a vertical line which will intersect with the horizontal line from A dash. This is the line. So this is the intersection point. Now you have to take A dash as the center and radius up to this intersection point, and then need to draw an arc. Need to draw an arc which will intersect with this locus. So we are drawing this thing with the help of true line. So we will get apparent line in the front view. So to create an arc, simply I am gonna create a circle. Center, take it as a center, and radius up to this point of intersection. So just going to remove this thing. I don't need this one, not this one, okay, and delete this thing. Select, delete. Now A dash as a center, radius up to this much. This point of intersection, we have created an arc which will intersect with this locus. This is drawn with the help of this true line. So true line will give true line in top view gives apparent line in front view. Just connect these 2 points, A dash and this intersection. So this is our apparent line in front view, and the end point is denoted by B dash. Now we have true line in top view, apparent line in front view. Now you know end effectors. Endpoints of apparent line appear on the same vertical line. Here A dash and A are on the same vertical line, so we will do the same thing for this one. From B dash, I am going to draw a vertical line which will intersect with this locus. So here it is intersecting. So this point is B, end effector of AB. So now just do one thing. Connect these 2 points A and B. So this is our apparent line in top view, because we have used this shortcut. End effectors of apparent line. End effectors is always for apparent endpoints of apparent line, and the endpoints of this apparent line, we know these 2 points lie on the same vertical line. A dash and A will lie on same vertical line. B dash and B lie on the same vertical line. So that is why we have used this shortcut to find out this apparent line. Now only a true line is missing in the front view. So with the help of this apparent line, we are going to draw our true line in front view. So from apparent to true, what we need to do is this as a center and radius up to this point B. You need to create an arc which will intersect with this horizontal line from A. So simply I'm going to draw a circle taking A as a center and radius up to point B. Now this arc will intersect with this A, with this horizontal line here. So I need this point of intersection. Now you can remove the excess part. I don't need this. Just select and delete. Now from this point of intersection, just do one thing, create a vertical line which will intersect with this locus, because this is the horizontal line where endpoints of true line apparent line will appear. So this is the point which is required. So this is the endpoint of our true line. Now connect this point with this A dash, and this point is B1 dash. So this is so now our projection is complete. True line, apparent line in the front view, true line, apparent line in the top view, and this is our side view. So in the question it has been asked, you have to draw 3 views. So this is front view, top view, and side view. Now to check whether it is correct or not, one shortcut already has been used, in which we have used the end effectors lie on the same vertical line. End effectors of front view and top view will lie on the same vertical line. So this has been used to find out this apparent line. So what we're gonna do is, so next thing which we can use to check whether this is correct or not is true line, length of true line. In both cases, true line should be of same length. So let's check here. In the front view, the true line is of 80.8 mm, and here in the top view, true line is 80.8 mm. So both true lines are of same length, so this projection is good. This projection of line is correct. As you know, there is only one line which will be inclined with HP as well as with the VP, and after applying both this condition, you have to draw front view, and you have to draw apparent line in the front view, apparent line in the top view. So the true line should stay, or should be of same length in both cases. That is why this is a way to check whether our projection is correct or not. So now in question it is asked to find the true length and true inclination with HP. So true length is 80.8 and true inclination with HP is angle created by true line with HP, which is 22 degree. Just Okay, so true inclination with HP is 22 degree. That's it. Again, I'm going to find out the, okay, no need to find anything because in the question it has been asked true inclination. So the angle drawn by true line with the HP is true inclination with HP. Or you can just find out the apparent inclination with HP is 29 degree and apparent inclination with VP is 44 degree. So just now change it to mean time. So this is our projection. So that's it. This is a complete projection of this particular question. Thank you.